So sorry about that.
Good afternoon, everyone. We have the second EE theme of the afternoon, automated attendance. Guys, are you guys ready?
Yes. Ready.
Go.
Hello everyone, thank you so much for being here. My name is Christian Miranda. I'm here with my fellow team members, Hassan Saleh, our archivist, sorry about that. He Dang, our financial officer, Yared, our handle testing, and Angel Rodriguez for design and production. So our project is an automatic attendance system. Gonna go ahead and pass it on to Hassan to give us a further introduction to it.
Alright, so that's the problem. Taking attendance in large class is time consuming. Since there's going to be a lot of students in class, and the professor is going to take a lot of time just taking every individual. It's going to be interesting since the students are going to be in class and waiting for the professor to end the class, and they already have their attendance credit. It's going to take more effort for the professor to take every individual student. So if you have like 100 students in class, so that's going to take a lot of effort, just calling every student by his name. And it's going to be somehow inaccurate since sometimes sometimes arguments going to be between the student and the professor. There's going to be arguments, like if he was in class or if he's not in class, and he's not going to take like the credit points. So our solution for that is automating user identification using facial recognition. We developed an attendance system using GUI. We had a database to keep the students in a list. And the overall goal is to create a template system that is high speed and high accuracy with a minimal human assistance. I'm gonna pass it to Christian Miranda, and he's gonna, Angel Rodriguez, and he's gonna talk about the design stuff.
How are you doing? All right, I'm Angel Rodriguez. The first step in our facial recognition pipeline is facial detection. Face detection poses an interesting challenge because of variations in the detection environment. Examples of this are variations in pose, variations in illumination, and occlusions of the face. Because of this, we have chosen a proven face detection model called an MTCNN, which stands for Multitask Cascaded Convolutional Neural Networks. This framework exploits the correlation between face detection and phase alignment to improve performance. Essentially, the MTCNN is 3 neural networks strung together to give specific outputs. The first output is the location of the bounding box where the network thinks there's a face. The second output is the confidence level in that bounding box that there is a face in that box. And the third output is the landmarks inside the box, which are the center of the 2 eyes, the center of the nose, and the endpoints of the mouth. So essentially what it does is captures every face that comes across the frame, puts a bounding box around it, crops it, and prepares it for the next step in the identification process, which Christian Miranda will now explain.
Thank you. So the next big part is FaceNet. And what FaceNet is a convolutional neural network that specializes in facial structures. What it does is it extracts embeddings from faces and images, and in our case, these images come directly from MTCNN, as Angel just described. And what an embedding is a numerical representation of a face in the form of a multidimensional vector. And the way the identification process happens is by the comparison of embeddings. So an embedding, identification match is made whenever a comparison yields the smallest difference. And the next part of the design is the GUI. I'll hand it off to Hassan.
So there are several files and scripts have to be extracted for the system to run as a whole. The GUI, its main purpose is to extract these kind of files and to run the system as smoothly and as accurate. It gives the user the power by just pressing by the press of a button to control the whole system. and it classifies every class and section by itself. And then after that, it classifies every individual in every section or class. I'm gonna pass it to Angel Rodriguez. He's gonna talk more about the design flow.
All right. This is the pipeline for our facial recognition system. For a person to be detected, he must first be enrolled. He has to put his information into the system, and then it will capture the frames. So we use the MTCNN for the face detection and alignment, which will extract the location of the face. When the face is extracted, it goes to feature extraction, which will extract the embedding from the face, which will then be saved in the database along with the pictures for later comparison. Once a person is already in the system and the system is running, he would walk past the camera. The MTCNN will do the face detection and alignment. It would output the location of the face, which will then be cropped and aligned for feature extraction. But this time it will go to feature matching. And it will compare the embeddings that are already saved, and it will look for the smallest difference. And if it passes the threshold, the user is marked present, and the list is saved. And after the system is shut down, a CSV file will be saved with the date and the names of the people detected for that class. Now I pass it on to Hee Dang to talk about more in detail about our registration process.
Hi, I'm Hee, and I will talk about the system registration.
Go back.
This is our first GUI window where the professor can create a new course. The second window allows the professor to add in the course name. The program will create a file for the course in the system. For step 3 and 4 here, this window allows the student to add their name and take his or her picture. This information will be stored in the course folder, and that's the whole process of adding a student. Once the professor done adding every student, the system is ready to use. Until the next class, the professor only have to choose the right course and hit and start the program. Next is system material. One of our design goals is to design a system that is small and mountable. Here's how our system connected. We chose the Jetson TX2 because of its dedicated GPU that can handle high-speed calculation, and it has a small factor form. The Logitech C270, we chose this camera because our system doesn't need high resolution images to achieve high accuracy. And this camera is budget friendly too. We also add the LED light strip to the camera to prevent the situation when the classroom is under dim condition. The touchscreen, we chose this one because we want something small and mountable next to the camera, so it will give the user the confirmation that he or she has been detected. And this is our bill of material. Every cost has been listed, and our total of the system is $550.59. Now Jared Mama will talk more about the interesting decision and result.
Okay guys, through multiple testing procedures, we were able to determine our strengths and weaknesses of our system. So one of the strengths that we feel very confident about our system is its high accuracy, And we were able to determine that by testing different individuals, and we were happy with our results, which we got 90% accuracy on everyone that we tested. And then the second part that we are a strength is the detection speed. We have 3 seconds or less. The face will be recognized within 3 seconds for within our system. So, and the weaknesses is one is lighting, which I will discuss in further detail in the next slide. And detection speed, even though we're happy with the results right now, we feel like that number can drastically get lower with future implementation. Okay, so the problem we were having with lighting is the system we're using, the way it detects face is it's using the dark and light contrast on your face, and the better you have a light source in front of you, the easier it is for the face recognition to pick up your face. So how we fixed that problem was when we were making our 3D mount for our camera, we added an LED strip inside the camera and inside the camera case, and that way we can add more light in front of the person who's getting captured. And we also would recommend to eliminate light from behind, which will cause shadows, and that way you will somehow reduce the lighting problem. And so after adding that implementation, we did testing again, and our specification for lighting is to have it at 127 lux of light per 2 feet. So if you would use it in that sense, then it would be ideal. And in the upcoming slide, I will pass it to Christian Miranda. He will talk in more detail what we did during our testing procedures and our results.
Thank you. So when we tested the system, we wanted to emulate the perfect, well, not perfect, but the environment that we recommend the system to be used in. As Jared had pointed out, our detection speed is not quite at the numbers where we would like, which is just a student passing by, not even having to pause and just look in the camera and detect them. So for our system, we recommend at least a slight pause. And we tested it with 3 of our members, myself, Jared, and Angel. And we gathered the data in the form of a confusion matrix because it truly encapsulates the performance of the system. It shows the true positives, the times that it was correctly identified, and something really important to note also is the false positives. This is a misidentification, which is for the nature of our system is the fact that we don't want any misidentifications, because then if someone is incorrectly identified, then that name would be put into the list and count as present. So from what our results, you can see for all 3 of us, we had 0 false positives. On the right table, you can see our accuracies are fairly high, but then again, how I said, the confusion matrix is really what encapsulates the true performance of the system. High accuracies does not necessarily mean high performance. And our numbers to the right of the accuracies, FAR, which is false acceptance rate, and the false rejection rate. A false acceptance rate is the tendency to take misidentifications. As you can see, we had 0 false positives, so those numbers are at 0. False rejection rate is a tendency just to say that person A is not person A, person A is not here. But with those issues, we've noticed it's not that big of a deal. All we need to do is sometimes maybe just look more directly into the camera or move a little bit closer, and then eventually the system will detect you and identify you. So for future expectations, how Jared had pointed out, we do want to improve the lighting, maybe add better lighting fixtures, implement 3D technology. So, because our system is currently using 2D images, we don't want the chance of someone cheating the system. Shrinking the neural network, making it faster, and making it even more compact, and also implementing infrared technology to get rid of the issues that's possible running into with our system. And right now, we're going to go ahead and give a quick demonstration.
start the program.
Takes a second to load the embeddings.
Right now what it's doing is calling up the FaceNet model. It's loading it up, accessing the embeddings, which is the embeddings of the students that have already been saved. Give me 1 second.
Loading again. Apologize for the wait. It's working out.
Tim, I'm sorry, you guys exceeded more than 25% of the time that any other team allowance. So I will suggest that you guys go through the questions and answers, and then we can present it outside for a meeting. Okay? Otherwise, whole thing will be same. Thank you, team. Questions? Yes.
So on some of the errors that it made, what did it confuse? Who did it confuse with whom?
Us too, most of the time.
Why didn't you test with a high?
We did it.
Oh, she was short.
She shows up good. The contrast in her face is good. Since me and him are dark and are not glossy, it doesn't reflect light real well. So especially me, I had the most trouble getting detected because of my skin complexion.
Especially like that.
Any other?
So how much training data does it take? So there are how many people programmed into this first?
Excuse me?
How many people did you program facial recognition for?
Right now, we just added the 4 students right here.
Okay,
Sure.
4 students. How much training data did you pass through for those 4?
The model is pre-trained. When you add the students, it automatically extracts the embedding from the student. So it does, we don't, it was trained on millions of pictures, but it was already done.
Oh, I see. You're using the internal FaceNet system. You didn't retrain your data.
Yes.
Okay. So even in your group, you were having false positives. Like my college has 30,000 students. How are you going to sub-segment the students in the database to avoid false positives? How does this mitigation going to occur?
So far with our testing, it has been so far quite rare for us to get false positives. The times that we implemented like a counter within our main script, because when we do receive false positives, it usually happens on 1 or 2 frames. It'll kind of switch off from, let's say, Angel is approaching, in that instance that he gets identified as Jared, it'll pick up Angel, and then maybe 1 frame, it'll pick up, it'll think it's Jared. So this counter, we set it up to where Angel has to successfully come up a certain number of frames, which like I said, whenever there's a false positive, it's 1 or 2 frames. So yet Angel has to come up until he's truly been counted present. For those 1 or 2 frames, it won't pass. So far it hasn't passed that threshold. So, because what we want is, like, if for the instance that we do get a misidentification, we don't want that name to be put in the list automatically. So, like I said, the person has to be identified in a certain number of times, and once they do, that's when they'll actually finally get registered into the present list, or to the list of those students who are present.
Yes.
So, when a student walks into, or I've seen they're facing the camera to be counted, does it indicate to them if it's accepted their image and if it's them, or?
Yes, so I mean, we can make a quick demonstration. Sonic would like to approach. So as he approaches, as you get closer, it pops up his name right there. He's been identified, and that's it. At that moment, right now, he's already in the list, and if he would like to also approach. So the way we wanted to implement the system is just have the camera pointing in the direction of where the students are moving on, like outside, leaving the classroom. All they have to do is just make brief pause and look directly into the camera, and it'll point to them if they've been picked up or not. If they haven't, it'll say unknown, and that's the instance when we say maybe look more directly into the camera. But it'll display their name under their face whenever they've been picked up.
One question:
Yes.
If somebody changes their appearance, like if they have facial hair and it grows longer, or if they shave it up, they have to re-register with the system, or is it going to be able to pick up those changes?
So far, it really hasn't made that much of a difference. Even with glasses, there's been times when we register ourselves. Me and myself and Angel, we wear glasses. There've been times where we register ourselves with or without glasses, and it'll still identify us. What we recommend is, like, for glasses, what people that wear glasses is, while they register themselves, do the 2 phases, record them, have the images captured, have the system capture their face without glasses, and then repeat the process without glasses. I mean, like I would said, the more data, the better, to really encapsulate how it is that they look like.
How likely am I going to be able to fool your system if I just had a photograph of somebody who was absent, chose not to go to class?
Yes, so that is possible. I mean, that's what I was saying. That's what we're wanting to implement for future works. Implement 3D cameras to move away from just those 2D still images get the depth of the pictures and technology that they use for like cell phones and stuff like that. So
And I guess finally, what do you do to secure your face database? So I can't hack into it and list everybody's present.
say that again.
What do you do to secure your face database, the whole system actually?
We just set up with permissions. Yeah.
That's good enough.
We can definitely implement better security, but just root permissions. That's the beauty of the Linux environment.
Any other questions?